Good morning, good evening, or good afternoon, depending on where you're joining us from today. We would like to welcome you to today's session of the Azure webinar series. Our topic today is Windows Virtual Desktop Deployment, Recommendations, and Best Practices. Before we get started, I'd like to go over a little bit of housekeeping. We do have subject matter experts with us today who will be answering questions in real time, so please pop any questions you might have into the Q&A window and we will get to them as quickly as we can. Also, on the top right-hand corner of your console, you will find a resources area. Any links mentioned in this session will be easily accessible for you there. Right below the resources widget, you will find a survey. Please provide any feedback you have around today's session. Finally, this presentation is recorded and you will receive a link to view this presentation on demand in your email within 48 hours. Our speaker today is from Microsoft. Christian, handing it over to you.
Thank you, Anita. So let me introduce myself. I'm Christiaan Brinkhoff and I work as a program manager at Microsoft. So if you want to connect with me, please feel free to look me up on Twitter and as well on LinkedIn. So let's start and talk you through what I have in store for you for the next 45 minutes. So in the first section, I will go deeper into the architecture as well as service limits on the platform, image management, as well as the VM sizing recommendations and the optimization tool that you can use to gain in user density and provide a better user experience for your users. FSlogix best practices, Teams best practices, and as well for troubleshooting. So if you, for example, do a deployment and that fails, what are the things that you can do to solve that or to troubleshoot in a way that you have some faster pointers in the resolution of the root cause. And in the end, I will have a call to action that walks through all the things that you learned today and beyond, so you can take that into account to learn even more on the things that you learned today. So let's start with the first section about the architecture of Windows Virtual Desktop. So Windows Virtual Desktop is a very easy way to understand desktop virtualization because it's separated in 3 layers, and one layer that you see in the middle is a platform as a service solution, which covers the web access, diagnostic, gateway, and brokering service, and as well the backend services like SQL. All those services are part of the Windows Virtual Desktop service, so you don't have to do maintenance or patches or anything relating to building that environment and connect and make that globally wide available. That's already done as part of this service. On the left side, you see the client part, so the endpoints that we support, such as Windows, HTML5 via browser, Mac, Android, and as well Linux. And on the right side, you see your own Azure subscription. So think about your desktops, your session host, your virtual machines, your published apps, as well as Azure Active Directory, traditional legacy Active Directory, and as well your FSlogix user profile file server, which can be stored on Azure Files or Azure NetApp Files to leverage another platform as a service solution. So if we zoom a little bit more in to a high-level architecture of Windows Virtual Desktop on enterprise scale, so what you can do if you hit a couple of limits that I'm going to explain in the next section, you can create multiple Azure subscriptions if you want to exceed the number of 5,000 virtual machines per Azure subscription. So 5,000 virtual machines doesn't mean 5,000 user sessions per Azure subscription. So you can run, for example, 32 sessions on one virtual machine. So let's get that right as well. And the limit on 5,000, or it is not basically a limit, but it's a recommendation of 5,000 virtual machines per Azure subscription. That is active only per region. So per data center region, that's active. So if you, for example, deploy in West Europe 5,000 virtual machines, and you deploy 5,000 in US Central, you can use the same Azure subscription. So it's only per region. So that's important to remember. And in that other subscription, you only have to put in the desktops and the applications, and for example the FSlogix profile container file server, so Azure Files, storage account, or Azure NetApp Files. So let's talk a little bit more about those service limits, and talk first about the general service limits. So 400 host pools per workspace is the first limit. 10,000 virtual machines per host pool is a limit that is active on the host pool level underneath your workspace. So you cannot create more than 50 application groups per single Azure AD tenant. So that means that you cannot create more than 50 application groups, but that doesn't mean that you can publish more than 50 applications. So we recommend that you don't publish more than 50 applications per application groups. So you can increase the number of applications published and separate that to different application groups and assign it to Azure Active Directory groups, for example, easily. So take that in account as well. And the Azure Virtual Machine session host names cannot exceed a character limit of 11 if you have a deployment of more than 999 virtual machines, because that is the extra character that comes in the auto counting prefix that we have built in our ARM portal. So let's talk a little bit about Azure ARM limits. So we recommend, as I said to you in the previous architecture slide, we recommend to not deploy more than 5,000 virtual machines per Azure subscription. And that's because of the ARM API throttling wide limit of 1200 per hour. So we think that 5,000 is a sweet spot and the max per Azure subscription per region. If you have multiple regions, you can deploy another 5,000 virtual machines in that other region as well in the same subscription. So to manage an enterprise environment with more than 5,000 virtual machines per Azure subscription in the same region, we recommend you to create an Azure Hub Spoke architecture. So basically have a primary Azure subscription where you have your Windows Virtual Desktop workspace, your host pool, and use a separate Azure subscription to create the virtual machines, to publish a desktop applications, and as well put in a storage account for your FSlogix profile container. So by default, you can deploy up to 800 instances per resource group, but Azure Compute doesn't have that limit. So there's no limit on the resource group side to create over, like, let's say 5,000 virtual machines per Azure subscription. So limitations that are active on the Azure subscription that I just explained. Another way to work around it to increase the sessions per Azure subscription is to increase the resources per virtual machine. So think about that you reach the limit based on D8 machines. So what you can do is upgrade to D16 or D32 to accommodate more session hosts in that like host pool environment in your workspace environment to don't hit that limit or don't hit that recommendation limit that I just explained. Another limit that is active is on availability sets. So as part of availability sets, you can only join 200 virtual machines, or also known as session hosts, to an availability set. So if you want to work around that, you can either create several badges of deployment, which automatically creates a new availability set, or you need to use the ARM templates that we provide to exclude the auto creation of an availability set. Very soon we will build that into the portal as well, which you know from our Windows Virtual Desktop Classic version. And the last thing is that we suggest best practice that we see in the field to join all your session hosts in separate resource groups. So that leaves you in a better position if you want to remove all your session hosts due to, for example, image management, to just remove the resource group, and then all the components in that resource group will automatically be removed because of that. So everything that I just presented to you is already documented on the Azure Solution Center. So as part of a field initiative with other colleagues, we worked together to publish all the limits as well as best practices that I just explained on the Windows Virtual Desktop platform, and as well on FSlogix to the Azure Solution Center platform. So you can look that up on aka.ms/wvd best practices and aka.ms/FSlogix best practices. And FSlogix best practices is something I will talk about later on in this presentation as well. So let's first talk about deploy Windows Virtual Desktop and talk about the different options that you have to deploy or to automate the Windows Virtual Desktop deployment. So first of all, since April, we released the public preview of the ARM portal, the Azure portal integration of Windows Virtual Desktop, which is now generally available. So you can use it in a production environment right now. And inside the Azure portal, you can start deploying Windows Virtual Desktop host pools, your workspace. Everything is very easy right now to do that. And I will show you in the next slides how you can do that yourself. Another option is that you use ARM templates, that you automate the deployment of Windows Virtual Desktop via ARM templates easily and adapt that in your current automation procedure, for example. And another way is using PowerShell or the REST APIs or the CLI, the Azure CLI code that we made available on Microsoft Docs in the last couple of months. So you have a variety of either use the GUI approach or the automated approach to deploy Windows Virtual Desktop. So Windows Virtual Desktop deployment recommendations are listed here in 6 points. So you need to have an Azure Active Directory. So that's the authentication mechanism that we use. So for example, if you log on as a user with Azure MFA, it uses the Azure Active Directory credentials as well. You need to have Active Directory. So Windows Virtual Desktop is a combination of Active Directory and Azure Active Directory. In the near future, we will move to Azure Active Directory as well. And to connect your Active Directory environment to Azure Active Directory, you need to configure Azure Active Directory Connect. Most customers already have that because they use other Office 365 and M365 services. So you need to use an Azure Virtual Network with an DNS server that connects to your Active Directory environment. So it needs to be able to resolve the DNS name and to join the new session host of your Windows Virtual Desktop environment to your Active Directory domain. So that's a very important step that sometimes is not going in the right way, and that causes like trouble in the deployment. And Azure subscription, of course, and as well, an application group that associates users to Azure Active Directory. So basically, if you have Windows Virtual Desktop group that needs to be configured to provide users a full desktop, you can pre-configure that, synchronize that to Azure AD, and use that to connect users to the right desktop, for example. So as I said, Windows Virtual Desktop is now completely available in the Azure portal. So if you go in the Azure portal to Windows Virtual Desktop, you will see the service, and you can directly start with creating a host pool. So as you can see here, it's very easy to do. And if you do that, you go into the first menu, and in that menu you need to provide your Azure subscription, your resource group, your host pool name, which can be random, the location of the metadata, which can be in the US in several data center locations, and very soon as well in Europe and as well in Asia. So stay tuned on our public roadmap for that. The host pool type can be changed to either pooled or personal. Pooled means Windows 10 multi-session, multiple session hosts that have the capabilities of multi-session, such as Windows 10 multi-session. And personal means a one-to-one, so one personal virtual machine per user. So most likely Windows 10 single session. So you can configure that here as well. So the next step, we will create the virtual machines. So we add virtual machines to the host pool. So the first step that you need to do for that is click on yes to provide the resource group virtual machine location, which can be an Azure data center region around the globe. Virtual machine size can be picked here. So you can pick any virtual machine size, compute size that is available in that data center that you select. So this is an example of West Europe with the D2, but you can go for D8 as well, or an N series with a graphical enhanced card inside for extra resources. You're given the number of virtual machines here and as well the prefix, so the name, the computer name of your session host. And if you are ready with the first two parts of that, you can select your image. So we can pick an image from the gallery. So an image that is pre-created from the Azure Gallery, which includes all the latest patches and updates as part of the build that you select, and as well the option to use one with Office 365 Pro Plus, which is now renamed to Microsoft 365 Apps for Enterprise. You can select the operating system disk type. We recommend to use SSD, standard, or either premium. And as well, the virtual network needs to be selected here. So select a virtual network that you already have pre-created, or create one here. A subnet where your session host will be joined to. You don't have to enable public IPs because we don't need that. No network security groups are needed for a normal deployment, but if you want to configure network security groups and block ports, that's all supported as well. Define the domain of your environment. So define DNS suffix and as well the distinguished name of your organizational unit if you have predefined some group policies, for example. So that's all supported. And as well the administrator account to provide the computer account creation, the domain join creation in Active Directory. So that's something that needs to happen as well, of course. So if you're done with that and you succeeded in all those tabs, you can go to the last tab, and that's creation of the workspace, which is previously known as the tenant. Previously in the classic version of Windows Virtual Desktop, you had to do that via PowerShell. Right now you can easily do that here via the Azure portal. You can just click on yes, you create a name of the workspace, and then click on OK, and then you're good to go in deploying the environment. So you get a validation, and as part of the validation you see if everything succeeds and it's possible to deploy. You can as well click on the optional option to save the deployment as an ARM template, so you can do that after the deployment again, and then, for example, in an automated way. So that's another capability that you can use. If everything, the validation is passed, you can click on create, and then the Windows Virtual Desktop deployment will start, and in roughly like 30 minutes you'll be able to provide users a full desktop or a remote app, as an example. And that's as well the reason why Windows Virtual Desktop has been so pivotal to extend remote working in this very bad COVID-19 scenario. So if you're done with the deployment of your first host pool, you need to assign users to that specific application group. So you can go back to the Azure portal and go to Windows Virtual Desktop, and then go to application groups, and then go to the assignments option, click on add, and as part of that you can select an Azure Active Directory group or user and assign that to that desktop or remote app, and then the user has access to that full desktop or remote app. So very easy, as you can see. So let's take this to the next level and talk about image management, because if you do a deployment, there will be a moment in the future that you need to update your images due to an application update or security patches. So what are the options that we can provide for that? So as part of image management options, we can use a couple of options as part of the Azure platform. So think about Azure Update Management that can be used for server-based operating systems, System Center Configuration Manager, or Microsoft Endpoint Configuration Manager, how it is called today. Can be used as well to manage and maintain your single session and multi-session images easily. The shared image gallery can be used. I will talk in the next slides more on that as well. And Azure Image Builder. And Azure Image Builder is a service that can create an image from scratch out of the Azure Image Gallery, which is up to date, and add your applications on the fly as well in an automated manner. So that's now publicly available as a public preview. But the GA will come soon, so stay tuned for that, because it's a great service to do image management in conjunction with Windows Virtual Desktop. And you can use Azure DevOps as well to create your images. And third-party solutions can be used as well. So if you have your own image management solution, completely automated build, we can combine it as well with the creation of your Windows Virtual Desktop images. So as I said, the shared image gallery is one of the services within Azure that you can use to manage your images, and as well to replicate and share your images to different regions. Because how the shared image gallery works is that you create out of an Azure Managed Image, or as part of your Azure Image Builder process, you create a new image version. And as part of that, you can replicate that image to different regions in your environment. So as part of your Azure subscription, and you deploy your host pool in different regions, you need to have that image in that region as well. And with the Windows Virtual Desktop service in combination with the shared image gallery, you can easily do that and select that as source while deploying your host pool, as an example. So in the creation of the Azure Shared Image Gallery service, you have the options, as you can see here, to define a target region. And that target region can be any Azure supported compute region, and you can replicate easily your image version or your new version to those different data center regions. So a very easy way to use a new image as a source for your host pools in Windows Virtual Desktop. And even better is combining that with the Azure VM Image Builder service, or AIB as a short name, as I explained earlier. And with that you can build based on JSON files or via PowerShell an image from scratch, add custom applications to it, and then export it as a destination to the shared image gallery. So a huge improvement in what we can do to the native capabilities of Windows Virtual Desktop while combining that with the Azure VM Image Builder. So definitely keep an eye out for that. And another great thing of the Azure VM Image Builder service is that you can combine it with Azure DevOps. So Azure DevOps is probably a service that you use for other components or other platform as a service solutions within Azure. And you can combine that with as well the Azure Image Builder, or you can use only the Azure DevOps service and use it as an image management procedure. So great solutions that you can leverage as well to simplify image management as part of Windows Virtual Desktop. So another very easy way to start your Windows Virtual Desktop deployment, whether it's a POC or production pilot or a production environment, while using the Windows Virtual Desktop Quick Start tool. And in the Quick Start tool, you can easily, in a couple of steps, deploy a complete Windows Virtual Desktop infrastructure environment on top of your Azure subscription. So if you are interested in that, you can go to aka.ms/wvd Quick Start to learn more about that. So let's start and talk a little bit about virtual machine sizing recommendations. So as part of multi-session operating system recommendations, such as Windows 10 multi-session, we have a couple of workload types defined, as you can see here. So light, medium, and heavy and power are the personas that we use for that. And as part of light, medium, heavy, we have several applications that we see as a persona. So if you go to aka.ms/wvd sizing recommendations, you will learn more about those personas. But what we see in the field is that the medium workload type is the most common one, and that reflects 4 users per core. And that means if you use a default for machine v3, that you can fit 16 users per session host. And what we recommend as well is to use a profile container size of 30 gigabytes, but that could be less as well if you, for example, have less retention of your Outlook caching configured. So heavy and power are common use cases as well for think about more corporate applications or manufacturing applications which need more graphical resources with an N series as an example of NVIDIA or the new NVV4 series from AMD. So all is listed on the page that I just explained, aka.ms/wvd sizing recommendations. So for single session sizing recommendations, we recommend to at least use 2 physical cores per virtual machine, and typically 4 in like a hyper-threading scenario. And for RAM, so for memory, we see that 8 gigabytes per single session virtual machine becomes the more standard, but we see some good stable deployments as well with 4 gigabytes as standard for their personal host pool. So D2S V3 or the new V4 series could be a good fit for that. So think about that while starting your personal host pool deployment. What we recommend as well, if you do user density measurements and you want to have the most efficient way of deploying Windows Virtual Desktop, is to use a software vendor like Login VSI to measure the maximum stretch level per virtual machine workload that you have as part of your application set. So another great thing that you can do to optimize your images is to use the Virtual Desktop Optimization tool, created by the Virtual Desktop team, or also known as the VDI guys in the past. So that team created a community tool, and one important note to mention here is that it is a community tool, so it's not officially supported by our support desk. Our support tickets will not accept anything related to this tool, but you can use it to optimize your images and download it for free on their GitHub page that you can find here. And if you download that, you can run the script, and then it will disable services that you most likely don't use as part of your virtual desktop environment. And then when you reboot it, you will get a better user experience as part of your deployment. So one extra thing that you need to take into account is that if you run this tool, we recommend you to run this tool after the sysprep of your image. So most likely during the first startup of your clean, new, fresh images as part of your host pool. So if you're interested in the Windows Virtual Desktop, or also known as the Virtual Desktop Optimization tool, this page, aka.ms/optimizewvd, goes to this community page that explains all the steps that you need to know about using the Virtual Desktop Optimization tool. So let's talk about FSlogix best practices. And first, I would like to give you some clear understanding on what FSlogix is. So FSlogix is a company that is acquired by Microsoft in November 2018. and has been the profile management fundament of Windows Virtual Desktop from the moment it got released. And FSlogix works in a manner as you can see over here on this page, and that includes an agent that you need to install on your image, and that includes a filter driver that is tricking the operating system that there are redirections in place to a virtual hard drive that is stored on Azure Files or Azure NetApp Files. That includes the Windows profile. And that creates as well the easiness if a user logs off from a session host and logs back on to a different session host, is that the Windows profile gets roamed to the different session hosts, and it does that in a very efficient manner because it leverages a block-based technology via the filter driver. So there's no copying or something happening while logging on that you know from roaming profiles. So it's a very efficient way of doing profile delivery. So to store your FSlogix profile container, there are 3 main options that you can pick as a storage location for your SMB configuration of FSlogix. So Azure Files is one of the options that you can pick, and with Azure Files you can use as well since a couple of months Active Directory authentication, so you can configure NTFS rights based on Active Directory groups or directly on a user for NTFS rights. That's all possible. Azure NetApp Files is around for a longer time, provides similar benefits in terms of the platform as a service benefits, so you're not responsible for the backend. And Storage Space Direct is a self-managed solution, so you leverage IaaS, but you need to maintain that virtual machine yourself. So I'm not going over all those steps here, but I encourage you to go to aka.ms/FSlogix best practices. That goes through all those differences of all those different solutions, so you can pick which is the right one for your use case. So as part of FSlogix profile container, if you configure that, you need to install, of course, the FSlogix agent inside the image. You can automate that as well. But as part of the configuration, you need to configure at least enabled and VHD locations. Enabled needs to be set to 1 as a registry key in software FSlogix profiles. And VHD locations holds the share location, the UNC path, to, for example, Azure Files or Azure NetApp Files. So that are the mandatory 2 keys that you need to use for FSlogix. So some other important configuration options that are optional but best practices that we see that a lot of customers are using is this first registry key, which is called delete local profile when VHD should apply. And this setting will remove the local profile if it already exists in the image. So normally if you don't configure this setting, you won't get an FSlogix profile container because there is a local profile already in that image available. So with this setting, you can avoid that, like a local profile is there and the user cannot log on with an FSlogix profile container. So a very good proactive way of removing errors in the near future while deploying Windows Virtual Desktop. Size in MBs is a setting that you can use to change the size of the profile container. So standardly that's 30 gigabytes. It's dynamically expanding. So that means that the size is not 30 gigs from the moment it gets created, but it means that it can stretch up to 30 gigs. So if you want to lower that max level to 15 gigs, you can change that to 15,000 as a value size, and use this setting to proactively size the profile containers of your deployment. Flip-flop profile directory name is the setting that you can use to flip the name of the creation of the profile container folder. So normally that folder is created with SID and username, and with this key you flip that to username and then SID, which makes it easier to search for example, the username in that folder if you do troubleshooting as an example. And the last setting which we see happening quite often is a volume type setting, which can change the format to VHDX. So there's no real performance benefit of going from VHD to VHDX, but VHDX has some more capabilities with, for example, PowerShell. These are the 4 settings that we see at a lot of enterprise deployments that are becoming mandatory and kind of best practices for a lot of businesses. So as part of Azure Files, if you go down the road of Azure Files, You have some other best practices as well. So if you use Azure Files, you need to create a storage account, and that storage account will be joined as a computer account or a service account to your Active Directory environment to provide AD authentication. And therefore, your storage account cannot be larger than 15 characters because the computer account will be created as the name of the storage account. So think about that. Keep that lower than 15 characters. So Azure Files Standard and Premium operates differently. So with Azure Files Standard, you can fill in 10,000 IOPS per storage account, and Premium can fit on 100,000 IOPS per storage account, and the latency is lower as well. So internally, we have a rule of the thumb, and we have that documented as well on the AKMS/FSlogix best practices page, is that in a steady state, a user normally consumes roughly 10 IOPS in a steady state, in an idle state, and 50 IOPS during the sign on and sign off process. So for light personas, we see that standard Azure file shares are great. Medium, we see that standard becomes, for the vast majority, still good enough, but premium becomes better to, for example, stretch up your environment in the future, and the same for heavy and for power. And one way to increase the amount of user sessions per storage account is to stack up your storage accounts. So with the Azure Files Standard SKU, you can fit on 10K IOPS per storage account. If you use Premium, it's 100K. But with the object-specific setting of FSlogix, you can filter based on Active Directory groups. And based on that, you can create multiple VHD location settings that are filtered on Active Directory group. So if you're part of that group, you will get another storage account provided as part of your registry keys as FSlogix. So you can easily accommodate more IOPS and more user sessions because of that. So that's a way to stack up your deployment easily. And you can use Azure Files Standard and Premium for that. So the object-specific setting that is being used in this slide can be found at AKMS/FSlogix as well. And in there you can find everything how you can configure your own filtering based on Active Directory groups as an example. And another important step while optimizing your images and make sure that the user performance and the density and your consumption eventually is what is expected in the design is as well the configuration of FSlogix antivirus exclusions. So if you configure FSlogix in your environment and you have an antivirus installed, you need to exclude the processes of FSlogix and as well the VHD and VHDXs that are stored on Azure Files, for example, or stored in the temp directory if you use concurrent sessions. So please make sure that you configure the exclusions properly, because that could cause more CPU load because the VHD, the profile container, is being scanned during logon as an example. So I really recommend you to proactively include those exclusions and use your security team to do that. So another important part which we see as becoming a more standard application inside Windows Virtual Desktop deployments is Microsoft Teams. And we recently announced a Microsoft Teams audio and video redirection for Windows Virtual Desktop. So you can now offload your audio and video traffic to your endpoint easily while using the audio and video plugin that you need to install inside your Windows Virtual Desktop image. And before you use that and you do a call inside a session, you will see that your CPU spike go roughly up to like 10-11 CPU per user. And after the implementation of the AV redirection plugin, it will go down to roughly 1%, and the audio and video traffic will be optimized as well. So to prepare your network for Teams, it really depends on what the quality level, if you use a camera, if you share your screen. But this is the table that we use to prepare customers to which kind of scenario is active for Teams. And these are the same kind of scenarios and bandwidth requirements that you have for Teams in a physical desktop scenario. So if you're interested in this, go to AKMS/prepare Teams, and you will find everything related to prepare your network for Microsoft Teams as well with Windows Virtual Desktop. So another reoccurring question we get quite often is the size of Teams inside your FSlogix profile container. So there is a possibility to slink to decrease the size of Teams inside your profile. So the two locations that you see over here, so the Microsoft/identity cache and as well Microsoft Teams folder, need to be always included inside your FSlogix profile container. But all the other folders that left behind can be excluded potentially. And you can use the exclusion redirections XML file within FSlogix that you can find on aka.ms/FSlogix exclusions, how you can do that, and do some data management on that as well. So let's use all the knowledge that you just learned. And if you are not an existing Windows Virtual Desktop customer yet, this section would be very interesting for you. So what do we see going wrong while deploying Windows Virtual Desktop quite often? So in the beginning section, at the architecture section and the deployment section, I already talked through that Active Directory is still needed for Windows Virtual Desktop. So as part of Active Directory, you need to join computer accounts to Active Directory. So to connect from your Windows Virtual Desktop from your Azure subscription to your domain, you need to make sure that your VNet is able to connect to your DNS service as part of your Active Directory domain. And make sure that the account that you use for that to connect to your Active Directory environment, to join and create those computer accounts in your Active Directory environment, that they have the proper Active Directory permissions for that. So that's something we see quite often going wrong, and then your deployment fails as well. So if you receive a domain join failure in your Windows Virtual Desktop deployment, then what you can do to troubleshoot that is to try to join a virtual machine inside your VNet, just a normal virtual machine, and set up an RDP connection to that virtual machine, and try to connect from the control panel to your domain manually, as you did probably in the past yourself from your own physical desktop PC. If you then get an error as well, then you know that either the credentials are wrong or the domain name cannot be resolved because the DNS server is not the right one. So another important thing is to attempt to use a different virtual machine. So it could be that there's something wrong in the virtual machine itself. You can use a new virtual machine and see if that solves it. It could be as well that the computer account in Active Directory is still there and you first need to remove that. So you can sort of test that while creating a new unique virtual machine name. And the last one that we see happening quite often in enterprises is that the access to the Active Directory environment is delegated to certain organizational units. And if you don't set up the distinguished name in the deployment, that you don't look at the right organizational unit, and then you don't have the rights for that, and then your deployment will fail eventually as well. So to do more troubleshooting of your Windows Virtual Desktop deployment, whether it's like a deployment or a production scenario, since we moved completely to the Azure portal, we now have the option to use the Diagnostics service that connects and makes it possible to export all the loggings, the diagnostics of your Windows Virtual Desktop, your managed Azure platform service to Azure Log Analytics. So as part of that feature, you can now easily inside the Azure portal go to Diagnostic as part of your host pool and as well your workspace and export the diagnostic settings directly into Log Analytics. And as part of recent announcements during Ignite, we have Log Analytics workbooks now available that can create visibility in your Windows Virtual Desktop deployment easily, as you can see over here as an example. So you will see how many daily sessions users are active in your environment, and you can run queries to gather information of your Windows Virtual Desktop deployment, and as well, for example, sessions that are happening, and as well errors in your environment if you need to troubleshoot if a user cannot connect to your Windows Virtual Desktop deployment, as an example. So I really encourage you to look at Log Analytics, because that can make life a lot easier while doing troubleshooting of your Windows Virtual Desktop environment. So that brings us to the end section of this presentation, and that's the call to action. So let's share some resources that you can use to train yourself even more, or to use some of the resources that I used today as well to gather the content of this presentation. So the overview section of WVD gives you everything related to the service. So if you want to learn more about WVD, please go to AKMS/WVD. The WVD and FSlogix best practices that I used earlier can be found at AKMS www.wvd best practices or FSlogix best practices. Microsoft Learn recently released a new module on the Windows Virtual Desktop Azure Portal integration, so I really encourage you to train yourself and use that on AKAMS/LearnWVD. The WVD Quick Start tool is very good to use and to start and kick the tires very easily on your Windows Virtual Desktop deployment. And the friends from Microsoft Mechanics did some great video series on Windows Virtual Desktop recently as well. So I really encourage you to look at one of those resources over here. So that brings us to the end of this webinar, and I would like to hand it back over to Anita to close this out. Thank you.
Thank you so much, Christian. This does conclude the audio portion of our webinar. If you haven't already, please submit your questions into the Q&A window. Please note that the questions and answers are available every time you access your webinar console with the on-demand link. Thank you so much for joining us today, and we hope to see you in an upcoming webinar soon. Have a great day.